So we deal with today's questions. The first questions ask me to talk about the probabilities of many kinds of process. So the first process is the Poisson process. This process has been discussed in the class and the previous homework, so we can directly see the possibility mass functions, and the expectation of the mean is just equals to lambda times t, and its autocorrelation functions is just equals to lambda squared times t1 times t2 plus lambda times the minimum of t1 or t2. The second process is the Poisson increment process, and it is also very easy to understand it. We can build up two Poisson processes. First is the point dropped on the interval 0 to t1, and the second is the point drops to the interval 0 to t2. And then the Poisson increment is just equals to the point dropped on the interval t2 minus t1, and then divided by t2 minus t1. So we can easily find out that it is also its mass function is also based to the Poisson process, and its expectation is also similar to the Poisson process. In fact, it's just the lambda times t2 minus t1. It is because that the answer of this process, or it is that the x of its process is not equals to 1 as the Poisson process. It is just equals to 1 over t1 minus t2. So the product is the final answer, and it is also the expectation, so it is lambda. Also, the autocorrelation functions is very similar to the Poisson process. Well, we need to calculate the overlap, and if t1 minus t2 is bigger than sigma or smaller than sigma, and finally the answer is look like this. The third is the Poisson impulse process, and this is just a derivation of Poisson process. So we can easily find out that the mean is just the derivation of the mean of the Poisson process. It is equals to lambda. And the autocorrelation function is just equal to the limitation of the autocorrelation of the Poisson process, and it is equals to lambda squared plus lambda times the impulse function of t1 minus t2. The first is a semi-random telegraph signals, and this is just a signal that's some. For example, we threw many times of the coins and calculate the number of it's not true, very sorry. For example, it's just like some points, some lines randomly flashed, and we calculate the time of each flashed, and if the number of the flash time is even, we get 1. Answer is 1. If it is odd, we say the answer is 2. Is minus 1, and this is just equals to semi-random telegraph signals. So it is very similar to the bi-distribution process, and we can also calculate the density functions and the mean expectations and the autocorrelation functions. And the fourth is the random telegraph signals. We can say that the semi-random telegraph signals, when it is equals to 0, when t is equals to 0, the answer of the process is always 1 or minus 1. But in random telegraph signals, when t is equal to 0, we don't know x is equal to 1 or minus 1. They are equal probabilities. So in that case, we can say that the mean of the process is just equal to 0. And the autocorrelation function is just equals to e to minus 2 times lambda times the absolute of t1 minus t2. And then in the random walk process, it's just this is just looks like we threw the coins. When the number is upside, we plus 1, and when the flower is upside, we get minus 1 and add them together. The final answer is the output. So we can easily calculate the probability mass functions and mean expectations and autocorrelation functions. And if we take some limit, such as s is go to 0, t go to 0, and n go to infinity, the random walk process go to the winner process. Winner process is just used to describe some very small things such as quantums smooth, and its mean is equal to 0, and its autocorrelation function is just equals to alpha times the minimums of t1 and t2. And then the second question is ask us to collect the definitions of many stochastic process. The first is the WSS process, wide-sense stationary process. In this process, it just need the process expectation is independent of t, and its autocorrelation function is just depend on the t1 minus t2. The second is the independent increment process. We can also see that the concept is just over the paper. The third is the Markov process. This process is very interesting. If we know the second order distribution function, we can absolutely determine the process. It's just equals to we walk on the road, and what we walk just where we walk just depend on previously what I was. It's not depend on some other things, just depend on where I was. Okay. The first is a normal process. That is just a process in any time t is jointly normal. For the 5 is the strict sense stationary process. That is that the nth order density functions is independent of the time shift. The 6 is the white noises. It is said that the mean of the process is 0, and the autocorrelation functions is just look like q of t1 times the impulse functions of t1 minus t2. And the last one is the mean ergodic process. I think that is just equal to that is just that the process expectation is just equals to we take one of the samples and calculate the samples expectation of the time, and they are just equal and independent of time. In that case, the process is the mean ergodic process. That's all.